Welcome to Python Programming for Pharmaceutical Sciences. If you're a B.Pharm student looking at your new syllabus, you might be wondering why you're being asked to learn how to code. For a long time, the work of a pharmacist centered on the physical handling of medicine, like counting pills on a tray. While those patient-facing roles remain essential, the pharmaceutical industry now operates on a global digital scale. Developing, testing, and monitoring medications today involves managing more information than any person could handle by hand. This shift has created new career paths, from using artificial intelligence for drug candidates to bioinformatics analyzing genetic data. Modern pharmacists work at the intersection of medicine and computing. Because these fields rely on processing massive data, researchers use Python. Its syntax is designed to be readable, almost like plain English. Your medical expertise is still your greatest asset. Python simply provides the means to apply that knowledge to the massive datasets used in modern drug development and healthcare. The central challenge in today's labs and hospitals is the sheer volume of data. A single clinical study can generate millions of individual data points. Manually checking 10,000 patient records takes months. Python processes this data into clear charts in seconds. It also organizes thousands of scattered pharmacovigilance reports into a single searchable dashboard. And in drug discovery, Python automates screening millions of chemical compounds, identifying viable candidates instantly. Python acts as a lever for your career. It allows you to automate the repetitive, administrative parts of data entry so you can focus your time on the actual science of patient care and research. Many students feel anxious about learning to code, but programming is actually a very human activity. It is simply the act of giving a sequence of clear instructions to a computer. Think about making tea. You follow a logical sequence. Boil water, add tea powder, add sugar and milk, boil again, and filter. Programming follows this exact logic as a data recipe. The computer executes every calculation in the exact order you set. The only difficulty is that computers don't naturally speak our language. They operate on binary, a complex language of ones and zeros that is nearly impossible for humans to write efficiently. To bridge that gap, we use Python. It acts as a translator, taking your logical instructions and turning them into something the computer can execute. Python is especially friendly for beginners because it avoids the complicated symbols and strict formatting found in other languages. If you can write a clear sentence in English, you can learn to write a clear instruction in Python. Coding is just the process of writing out a logical plan. Python is the most straightforward tool available for putting that plan into action. As we start the first unit of this course, keep in mind that we are starting from the very beginning. We don't assume you've ever written a single line of code before. First, we'll set up your tools, showing you how to install Python and use an IDE. Next, we'll learn how computers think using variables, containers for information, and data types. Finally, we cover mathematical operators and libraries of pre-written code for complex scientific tasks. These concepts are the foundation. Once you understand these basics, you'll start creating your own programs to solve real-world pharmacy problems. Mastering these fundamental building blocks is what will allow you to work with the advanced digital tools used in today's pharmaceutical research and hospitals. Learning to code involves a lot of trial and error. You will encounter bugs and mistakes, and that is a normal part of the process. Every time you fix a mistake, you become a more capable programmer. By adding these technical skills to your pharmacy education, you are preparing yourself for the future of healthcare. I'll see you in the next chapter, where we'll get everything installed and ready to go.